Okay, so exploring the properties of logs. Shh. So let me get you guys, we're going to wrap up what you've been working on. You've been working for a few minutes on the top. So a logarithm is we kind of talked about it a little bit. It's an exponent. It's the inverse of, an exponential equation. A logarithmic equation is the inverse of an exponential equation. So your calculator only uses, we talked about this yesterday when we took notes on the yellow sheet, it only uses the common log and the natural log. So did you guys remember common logarithms are logarithms with a base of what? Would you put on that blank? Good, 10. And they're written as just log. Okay, so when you see just log, if you're going to do that, rewrite it as an exponential, it might help you to write the 10 on it. Okay, it's kind of like with a square root. We know it's taking out groups of 2, but they don't put the 2 as an index number because it's just assumed it's a square root. Log is like that. You assume it's base 10. Natural log, which is the key on your calculator that looks like capital L, capital N, are logarithms with a base of, remember we talked about that yesterday a little bit? E. And it's a key on your calculator, like the pi key. It's a second function key, and it's above division. So when you see a natural log, it's going to be written as ln. They don't put the base E on it. Let's look on your calculator, and we can figure out how to see what E is worth. Oh, there we go. Okay, so you don't have to today, but later in the unit, you're going to want to use the value for E. So it's a second, and it's written above division in blue. That's E. Press enter, and it tells you it's an irrational number like pi. It never ends. Scientists arrived at this number as the best way to calculate like growth in nature or decay in nature. And so, so it's a constant, and it's better to use the key E so you don't have to round it. But it's about 2.718. So if you were to be asked that, you could find it in your calculator. So it's about 2.718. But we're rounding because it's an irrational number. It never ends. Since logs are nothing more than exponents, the rules come from the rules of exponents. So you'll notice when you think about the exponent rules, it's the exact inverse. It's the opposite. It's the opposite of what you would think. So use your graphing calculator to evaluate the following. So the way you type them in, so this one is log 1. You just press log 1, and you should always close the parentheses. And it gives you 0. The other one was natural log 1, close your parentheses, and it gives you 0. So on those blanks, we know this is 0, and this is 0. Oops, maybe let me move it over a little bit into my arrows. God bless you. So we were kind of talking about, when I got you all started, that if you see log 1, you can write that little base 10. So when you do the lasso, it helps you know that the little base becomes the big base of the exponential. And then next is the power. That's my power of 0. There we go. And it equals 1. So this is the exponential. And the log is log of 1 equals 0. So when you rewrite it, it kind of makes sense, right? Anything to the power of 0 is always 1. If you forget, raise it in your calculator. Any number you type in there, raise it to the 0, you get 1. So same thing for this guy. And so it's easier if you write the E base on, so you can circle the base. And then when you do your lasso, E to the power of 0 is 1. Anything raised to the power of 0 is 1. So the inverse of that, the log rule, is the log of 1, no matter what the base, always equals 0. So Log base b of 1 equals 0. Log base 3 of 1 equals 0. Log base 8 of 1. Doesn't matter what the base is. So that is our rule. So I'll let you guys go a little bit farther, and then I'll check back in and we'll develop that rule. It's here. Okay, so I'm going to make it do it separate. No, it kept going good. Okay, so y'all wrote the base on it. So you said it was log base 10 of 10. And you said log, when you typed it in your calculator, log 10 is 1. Natural log E is 1. So you needed to know where that E button was. Did you use the E button? Good. So if you're going to rewrite it as an exponential, circle your base, do your magic lasso, 10 to the power of 1 equals 10. Does that make sense? Anything to the power of 1 always equals what? Itself. Good. So we write the E on there, circle the base, little base becomes big base, power of 1 equals E. Okay, so anytime you take the log of the base, which means they match, the base and the number match. See the log base 10 of 10? They match. It's always going to equal 1. So the rule would be log base b of b is equal to 1, because they match. And so that will help us simplify things when we see that one. So what did you get? Somebody read me their answers and I'll write them on here. What was log 3 plus log 8? What'd you get? $1.380. Then what'd you get for the second one? Good, 1.041. And then what did you get for the third one? Okay. So what did you notice about those three answers? They are. You see, you're right. They're all greater than 1. They're all decimals. Anybody notice anything else about those three when you compare those three? The first and the third answers are the same, right? So this is the same as this one. So it says log 3 plus log 8. But when I take log 11, which would be 3 plus 8, it's a different number. But when I take log 24, like Milana said, if you multiply 3 times 8, you get 24. They're the same. Okay? I want you to think about the exponent rule that this is like, because logs are inverses. So it's kind of like if I had to multiply x squared times x to the third, what would I get? What was the rule for exponents? When you multiply with exponents, what do you do to the exponents? You add them. So when you multiply with same base exponents, you add the exponents. Okay? When you add with same base logs, what do you do to the numbers? Multiply. So it's the exact opposite. So over here, what did you guys get? 2.996? Something like that? Okay. And then what'd you get for log 9? It's different though, right? I had 197. And then this one's the same. So when you're adding same base logs, you actually multiply the numbers. Okay, so I could write my rule is log base b of a plus log base b of c equals, and I'm compressing it, so I'm only using log base b once of a times c. Okay, so you can rewrite addition with logs as multiplication. So you'll take a minute and use that rule to rewrite these. Okay, maybe let's do one together. What would the first one be? Log base 3 of 6 plus log base 3 of 7. So I can rewrite it using log base 3 one time. And what's the new number when I put them together? 42, because you're multiplying the 6 and the 7. Very good. So you'll try to finish those up on your own, and then we'll check. See how you did. Okay, so kind of check your answers for those. I walked around and you guys seem like you were doing a pretty good job. Let's look at the next one. So you're going to enter log base 10, log of, well, it is base 10. It doesn't have it on there. You don't need that when you rewrite it. Just write the same log base 10 without the 10. So you're just going to hit log 10 in your calculator, close your parentheses, and then subtract log 2. And then see what that pattern looks like, and we'll develop a rule. Can anybody predict what you think is going to happen based on the last rule? When we add same base logs, we really rewrote them as multiplication. When we subtract same base logs, what do you predict might happen? Yeah, that's exactly what's going to happen. So go ahead and fill it out, and you'll check, and you'll catch that it's division. So the connection for exponentials is if I had something like x to the 5th over x to the 3rd, that's really x squared, because I subtract. When I divide with exponentials, you subtract. When you subtract with same base logs, you rewrite it as divide. So they are their inverses. So let's go ahead and we'll kind of finish that one up for subtraction. What did you get for this one, Jack? 0.699? 98, okay. And then what'd you get for the next one? 0.903. And then what'd you get for the last one? 0.698. I don't know why I wrote that word there. You don't need that. You don't need log, because we're just taking the numerical log to help us understand how to rewrite with the properties. And then what'd you get for x? Did you get natural log 15 minus natural log of 5? What'd you get? Savannah, did you do this? Did you get that far? What'd you get over here? You didn't do the right side? Okay. I'm going to take a second and do the right side, make sure they agree. So you're using that ln key. It has capital L, capital N, natural log of 15, close your parentheses, and then minus natural log of 5. You always have to close your parentheses or you'll get a different number. Mm-hmm. Well, we can leave it like that. That's fine. And then what'd you get for the next one? Was it 0.3? What'd you get for the next one? Was it the same as the top one? Okay, good. It's supposed to be. So these are the same. And so that rule, how would we write that? So when we subtract the same base logs, y'all said you divide. And so our rule is when you see log base b of a minus log base b of c, you can rewrite that using log base b of b one time to the a divided by c. So the first one is always on the top of the fraction, and then divided by the second one. And so they always give it to you in the right order. Okay, and the reason for this is we're going to practice rewriting logs again tomorrow, but after that we're going to learn to solve logs. And so when you have log base b and log base b, the matching bases on each side of your equation, written only one time, you get to cross them off and solve what's left. which is awesome. So that's the purpose of, you want to be able to rewrite it and get rid of, so you can cancel out log. Okay, so there's one more rule, and you're going to practice with this rule a little bit. So go ahead and practice with these, and then I'll kind of come around and, I'll come around and kind of check. So maybe let's do the first one together. So log base 3 of 42 minus log base 3 of 7 is really log base 3. 42 divided by 7 is 6. Okay, so we're just rewriting it. And you can write that in between step. Sometimes I think that's helpful when you're first learning how to do it. 42 divided by 7, and then you can simplify the 42 divided by 7. Okay, we rewrite subtraction of same base logs as division. So y'all try the rest, and then you should always simplify it as much as you can. Okay. So go ahead and check those 4 using that division rule, subtraction to division rule. Okay, the last part, so you're going to use your graphing calculator and evaluate log of 3 squared. Log 3 plus log 3 equals, and 2 times log 3, and see if you notice a pattern on that. Okay, so y'all had noticed when you ran your numbers that they're all the same. So let's think about this. Log of 3 squared. Log of 3 squared just means log of 3 plus log of 3, because that's how I would unmultiply 3 squared. So you guys looked at that one already. That was a property that we already looked at. And then the next one is another way to do it. So we already looked at rewriting addition as multiplication, so that means 3 times 3. The last way to do it is there's a rule that says when you have an exponent on your log number, you're allowed to move that exponent to the front. And then you can do the exponent as a number times the log. Okay, so you move the exponent to the front, and then you multiply by it. Because those are really the same thing. 2 times log 3, when I have log 3 plus log 3, is the same thing as multiplying it twice. So it's a shorter way of doing it. So sometimes you'll see problems like they're asking you to use this rule to rewrite. So if they're asking you to use this rule, well, this guy doesn't have an exponent. Log base, is that k? K of 8? So they're asking you to think of a way that you could rewrite the number 8 using a number with an exponent. So what's a smaller number that you could use an exponent and multiply to make 8? A 2, good. And so 2 to the 3rd power, good, 2 times 2 times 2. So sometimes you might see something like that because there's not an exponent on it, and then they want to see that you know the rule to kick the 3 to the front, and then it's just log base k of 2. So 3 times log base k of 2. And so you could do that with 24 also, but this one always, when people get to, if I don't say that, they're like, how do I rewrite that using that rule? So that's how you can rewrite, and you can do that to simplify whenever you need to. So this one, you kick it to the front, you should get 2 times log base, I think that's a 3 of 7. The numbers are so small on these worksheets. But they're nice because you can put them in your composition book. So kick the exponent to the front, 5 times L natural log of x. And then the next one, you could rewrite that. Do you want to rewrite it with a base of 3 or a base of 9? You could, either one. A base of 9, 9 squared. Then kick it to the front, so 2 times log m of 9. Okay, and if you had used a base of 3, I could even rewrite this one, right? I could say log base m of 3 squared to the 9, and then kick that one to the front, and then it would be 4. Because I already had a 2 there. Okay, so as simplified as you can get. So these are the ones that kind of help you pull it all together so you can do your homework assignment. And this is what we're going to be doing in class tomorrow. So if we look at, let's look at a couple of them. Let's look at maybe 26. Let's look at 29, 28, and 29. So 28, this is the only example. The very first thing when you see that radical is I would rewrite it as a fractional exponent. Okay, now you could probably simplify it. What do you do with a fractional exponent? Where does it go? So this is how you look at your log rules if you forgot. Where's the one with the exponent? You see it? There it is. So over here is where I'm going to look. The n that's the exponent goes to the front. Okay, so that's the only one with a radical. So I wanted you to have that example. This one, what would I do first? I always go for like what's in the middle. I look at it, it says x squared divided by 2 to the third. So really, the very first thing you have to do is break apart the things that are divided. Is that 2 to the third? Sometimes, again, it's hard for me to see the numbers. Yes. Okay. So when I break apart the things that are divided, what goes in the middle is subtraction, right? I rewrite division as subtraction because I'm expanding. So now I want to put the exponents in the front. When you've got an exponent on a log, it goes to the front of that log, not like to the front of the line. Okay, because the third is on this piece. So now I have 2 times, because I moved that exponent to the front, log base 2 of x minus 3 times log base 2 of 2. So I'm allowed to simplify a little bit further. Which one can I simplify a little bit further? They're not ringing bells? This one is just 1. Okay? I think it is 2.